Welcome back to this next video in which we are discussing cocaine. Okay, so we're currently in the process of discussing what cocaine actually does to the brain. So we've now discussed the cocaine high, and we've also discussed that cocaine doesn't actually last that long in the bloodstream. Okay, it has a half-life of usually around 1 hour, although the exact figure does vary depending on who you're talking about. And that's because cocaine is very quickly broken down by the liver into metabolites benzoylecgonine, ecgonine methylester, and norcocaine. Okay, so now what I want to talk about is the cocaine come down. Okay, so the cocaine high, this period of psychomotor stimulation, it doesn't usually last that long. It usually lasts about half an hour, and that's it. Then what happens is a couple of hours after the effects of cocaine have worn off, what happens is it goes in the opposite direction. Okay, so you get what's called the cocaine come down. Okay, so I'm now going to describe what happens in the come down. So in the come down, the subjective feelings are exactly the opposite of what happens in the high. So in the high, you feel extremely happy and excited, you feel euphoric, and you're also extremely alert and awake. In the come down, you feel in an extremely bad mood, so you feel extremely grumpy and not particularly happy. Okay, and the word for grumpy and not happy is dysphoria. Okay, so dysphoric. Okay, and you also feel quite tired, so fatigued. So I'll just put tired here. And as far as your behaviour is concerned, of course, your behaviour will go in the opposite direction as well. So you'll stop moving around, you'll want to move around less, and you'll stop talking as much. Okay, so you'll talk less than you normally would. Okay, so it puts you in a really bad mood afterwards. Okay, and that's called the cocaine come down. Now what I want to turn my attention on is to discussing cocaine addiction. Okay, so the first thing I want to do is define what is actually meant by addiction. Then what I want to discuss is how does it actually happen. Okay, so the question people always have is, how many times do I need to take cocaine before I'll actually become addicted? Okay, how many times can I risk taking cocaine without actually becoming addicted? Then what we'll do is investigate what this really actually feels like, and then we'll go on to the actual science, the neurobiology of how cocaine actually achieves these effects. So we'll go through why it causes the high, why it causes the come down, and what is understood about how it causes addiction. Okay, so firstly then, what is the definition of addiction? Okay, well the definition of addiction is that you continue to do something. In this case, you continue to go out and buy cocaine, so you continue to seek the drug, and then you continue to actually take the drug. So you buy and take the drug, even though you can see that it is destroying your life. Okay, so even though you can see that you mustn't take it, you do it anyway. You seek the drug, you go and buy it, and then you take it. Okay, so even though you can see that, you know, maybe your partner has left you because they don't like your drug habit, you're losing all your friends because they don't like your drug habit, you've lost your job, your bank balance is going down to zero, you might be losing your house, you might be resorting to criminal activity to get the money to pay for the cocaine. Okay, even though you can see that it's destroying your life, you will continue to do it. That is the definition of being addicted to a drug. Okay, and cocaine is extremely addictive. Its ability to do this to people is incredible. Okay, I think people often say it is the most addictive drug that we know. Okay, so how does this actually happen then? What's the sort of stages? Well, it's gradual. It's not a case that you take cocaine once and then you are addicted to it. You will take it every day following that forever. Okay, it's not quite like that. What happens initially is that people take cocaine maybe when they go clubbing or when they go to some cheap festival or something along those lines. Okay, they take it initially, they make the conscious decision to take the drug because they think it will be fun. Okay, and you know, they might go to a few festivals and have cocaine at each one of them, and initially they have conscious control over when they're actually going to take the drug. They can consciously say, no, I'm not going to take that. Okay, But then what happens is it gradually becomes more frequent. So they might start having cocaine once a week maybe, okay, and then it will end up being once a day, and then maybe multiple times a day. So it's a gradual process addiction. It's not a case that you take it once and then you're hooked, usually at least, okay. Usually if you take cocaine once, it doesn't actually reduce you to addiction that quickly. You need to take it quite a few times, and then eventually it will have you hooked, and then you'll start having to take it on a regular basis just to remain psychologically normal. Okay, so let's explore what actually is it doing. Okay, it has this incredible ability to take hold of the brain and make the brain seek this drug, even though the brain knows that this drug is bad for it. Okay, it's incredible the power of this stuff when you think about it, that it can do that to someone, that it can override their conscious control of their behaviour and reduce them almost into this compulsive behaviour out of conscious control, where they are seeking the drug and then taking the drug. Okay, it is truly scary, and what happens is that they get into a state where they are psychologically dependent on this drug. Okay, so that's a really important concept, and indeed they'll get withdrawal symptoms if they stop taking the drug. Okay, so I'll discuss the withdrawal symptoms. Okay, so if they were to stop taking the drug, let's say they have a habit now going with the drug, okay, so they take it on a regular basis. If they were to stop taking the drug, what they get is withdrawal symptoms, and specifically with cocaine, it's what's known as psychological withdrawal. Okay, now certain other narcotic drugs, particularly opiates, so morphine and heroin and things like that, they actually cause physiological withdrawal symptoms when you come off them. Okay, so if you have a habit going with opiates and you suddenly stop taking them, loads of your physiological systems start misfunctioning. Cocaine does not do that. Okay, when you stop taking it, it doesn't make you misfunction physiologically at all. It's all in the brain. Okay, it makes the brain misfunction, so you get psychological withdrawal, but you don't actually get any physiological withdrawal symptoms whatsoever. Okay, so what is psychological withdrawal? Well, it makes you feel absolutely awful. It makes you feel like you are physically ill, like you're extremely ill. Okay, so we all know what it's like to feel extremely ill. Okay, so if you've had a really bad dose of flu or something along those lines, you've taken to your bed, you feel awful, you're in a terrible mood, you can't think properly, you're tired all the time, okay, you're really, really grumpy, things like that. It feels awful, you feel awful. Well, basically, coming off cocaine makes you feel physically ill. It makes you feel like you're physically ill, even though you are not physically ill. It hasn't damaged you physically at all coming off the cocaine. Okay, so cocaine and other addictive drugs have the ability somehow to make the brain believe that it needs the drug to not be ill, and if it doesn't have the drug, it is ill, and therefore gives you the subjective feeling of as though you're ill, basically. Okay, and that's what is meant by psychological withdrawal. Okay, in addition, when you come off the drug, you will get incredible cravings. You will crave more of the drug. Okay, you'll crave going and buying the drug and injecting yourself with the drug, or however else you're administering it. Okay, so you'll get cravings as well. They're another important part of the withdrawal symptoms. Okay, so this is what is called psychological dependence. Okay, so cocaine establishes this control over the brain. It makes you psychologically dependent on the drug. It changes the structure of your brain, changes something about your brain, which now makes your brain believe that unless it has the drug, it is ill, and then if you don't have the drug, it will make you feel ill. Okay, and I should stress that if you then take the drug once again, okay, so if you've managed to resist for a few days, you're feeling really, really ill, and you then take the drug again, so you give in to your psychological withdrawal symptoms, then it will repair it. Okay, you'll go back to feeling normal. Okay, so you are psychologically dependent on the drug. You cannot function normally mentally. Okay, you cannot have healthy mental function unless you are taking the drug. Okay, so these drugs, cocaine and other addictive substances, because it's not just cocaine that does this, but we are talking about cocaine, so I should focus on cocaine. It has this ability to change the structure of the brain, make the brain psychologically dependent on the drug, and when you take the drug away, the brain will believe that you are extremely ill and will make you feel extremely ill. Okay, so it is quite incredible what this little molecule can do to the brain, and we will have a look at what is understood about how this occurs, but I should stress that we don't fully understand, of course, how this can occur. Okay, we only have the tip of the iceberg of an explanation as to why cocaine can do this to the brain. It is quite terrifying. Okay, so that now concludes the discussion of what cocaine actually does. Now the interesting bit, we get to actually look at what is understood about the mechanisms by which cocaine actually does this. So what I want to firstly do is discuss the mechanisms underlying the cocaine high. So why does it actually cause a high? Then what I want to discuss is the come down. Why does it cause that come down? And I should stress the come down would go away. Okay, this doesn't last very long. It would last maybe a day or two. Okay, but then it will go. Okay, so if you just take cocaine once and you haven't got an addiction with cocaine going, then you will get a come down, but it won't last for very long. Okay, so you have to take cocaine a lot to actually become addicted to it. Okay, right. So we'll then discuss the mechanism underlying the come down, and then what we'll do is look at what is understood about the mechanisms underlying addiction. Okay, right, so firstly then, let's discuss how the cocaine high is actually brought about by taking cocaine. What does cocaine do to cause that cocaine high? Okay, so in order to understand this, I need to tell you something about the monoaminergic systems within the brain. So we need to study a little bit of neuroscience to understand this. Okay, so what I want to tell you about is what's called the monoaminergic systems within the brain. Okay, so firstly let me draw a picture for the brain. So I'll firstly start by drawing a picture of the brain, because I'm going to need my picture of the brain to draw the monoaminergic systems on. Okay, so I'll draw a picture of the brain just for the setup here. Okay, so hopefully this is a picture that you will recognize as being a picture of the brain if I draw it well enough. Okay, so we are looking at the brain from the left-hand side. Okay, so we've removed the skull and we're looking at the person from their left-hand side at the brain here. Okay, so here is the big recognizable bit. This is the bit that most people recognize. This is called the cerebral hemispheres. Okay, this one is specifically the left cerebral hemisphere because we're on the left-hand side. On the right-hand side, it would be the right cerebral hemispheres. Okay, it's also called for short the cerebrum. Okay, so we'll call it that, and I've coloured it in there in yellow. Now, there are other portions of the brain, however, that's not the full brain. There's a bit down here as well, so I'll draw this on now. So poking out from underneath the cerebrum, what you're going to have is a structure called the brainstem, which looks kind of like this, which will then pass out of the bottom of the skull and become the spinal cord. So this is the spinal cord down here. Okay, so this is where it's passing out of the bottom of the skull here. Okay, and this is in green here, the spinal cord, which will go down the vertebral column. Okay, so the spinal cord there. So that portion that's above the spinal cord, it's the continuation of the spinal cord in the skull. So once the spinal cord passes into the skull through a hole in the bottom of the skull, a very big hole in the bottom of the skull, it becomes what is known as the brainstem. So this bit in orange here is called the brainstem. Okay, so this is called the brain stem. And then there's one final portion of the brain that I want to add on to this picture, which is the cerebellum, which sits behind the brainstem here and underneath the cerebrum. Okay, so this literally means little brain. Okay, so cerebellum, and I'll colour the cerebellum in a moment in vivid purple. Right, so there's our basic picture of the brain, so that I've got something to add my monoaminergic systems onto in a moment once I've described them to you. Okay, so let's now discuss the monoaminergic systems. Okay, so The basic principle then of the brain is that the brain is made up of loads and loads of nerve cells, okay? And these nerve cells can fire signals along, and they can influence other nerve cells' behaviour. Okay, now if one nerve cell wants to change the behaviour of another nerve cell, it needs to release a molecule onto that other nerve cell. Okay, and molecules that nerve cells can release onto other nerve cells to make them alter their behaviour are called neurotransmitters. Okay, now the two most common neurotransmitters that the brain uses are called glutamate and GABA. Okay, so most of the nerve cells in your brain use either glutamate as a neurotransmitter or GABA as a neurotransmitter. However, we're not going to be interested in glutamate and GABA. We're going to be interested in certain neurotransmitters that are called monoamines. Okay, so we're going to be interested in the monoamine neurotransmitters, and there are 3 monoamine neurotransmitters that are used in the brain. Now, the monoamine neurotransmitters are very, very rare compared to glutamate and GABA. Okay, most nerve cells in the brain use glutamate or GABA as their neurotransmitter to communicate with other nerve cells. Okay, but there are some nerve cells in the brain which use these monoamines instead. Okay, so what are the 3 monoamine neurotransmitters then? So I'll write them out here. Now, they're very famous neurotransmitters, so you might have heard of them before. Okay, one of them, which is going to be particularly of interest to us, is called dopamine, and for short, dopamine is abbreviated to DA, D for dope, and then A for amine. Okay, so dopamine, so that's the first monoamine. Then another monoamine is serotonin, again a very famous neurotransmitter that people generally know is to do with depression, so serotonin. And I won't give you the abbreviation for serotonin because it has nothing to do with the name serotonin. It's got to do with another name for serotonin, so I'll underline serotonin in green. And then finally, the final monoamine neurotransmitter is called noradrenaline. And in the States, noradrenaline is also called norepinephrine, so I'll give you that name as well. So norepinephrine. Okay, so these 3 molecules, and they are all different molecules, are the 3 monoamine neurotransmitters. Now, as I say, these are very rare neurotransmitters to actually be used in the brain. There are very few nerve cells in the brain which actually use these neurotransmitters. Okay, and nerve cells that use these as their neurotransmitters are generally clustered together in little areas of the brain. Okay, so let me draw this on my picture. So we might have a little cluster here in the brainstem here, which is a cluster of nerve cells which all use one of these monoamine neurotransmitters, let's say noradrenaline. Okay, so here then in the brainstem we've got a cluster of loads and loads of nerve cells which all use as their neurotransmitter noradrenaline. Now, what can happen is these nerve cells, which all have their cell bodies, so the main portion of them in this cluster here, can have projections, nerve fibers that go all over the brain. So they can send projections off all over the brain, and these projections will then release noradrenaline to these different areas of the brain. So this can go all over the place. It can even go down into the spinal cord. Okay, so this is the basic principle of these monoaminergic systems, that there are these clusters of nerve cells which use these special neurotransmitters called monoamines that are mainly positioned in the brainstem actually, which can send projections off all over the brain and release these special monoamine neurotransmitters into these different areas of the brain. So here's one for noradrenaline. We could also have ones for dopamine releasing nerve cells or serotonin releasing nerve cells. Indeed, we have lots of these. Okay, so for instance, serotonin, there are absolutely loads of these little areas in the brainstem which are full of nerve cells which use serotonin as their neurotransmitter, and these nerve cells send projections off all over the place so that releasing serotonin all over the brain and affecting the entire brain. Okay, so that's the basic principle then of these monoaminergic systems. The question now is, what do these monoaminergic systems actually do? Okay, we have these clusters of nerve cells which release these monoamine neurotransmitters and which send projections all over the brain, but what effect do they actually have? What effect does the monoamines actually have when they arrive at a certain area of the brain? Well, basically they affect the activity of different areas of the brain. Okay, so they can change the level of activity in different areas of the brain. So by changing the amount of these monoamines that they're releasing in certain portions of the brain, they can change how active that portion of the brain is. Okay, and the monoaminergic systems are actually important in determining whole brain characteristics. Okay, so they're important in determining things like your mood. Okay, so what sort of a mood you're in can be determined, or is thought to potentially be determined by how much of these different monoamines is being released in different areas of the brain. In addition, they're important in determining things like how alert you are. Okay, so this is looking hopeful then that this might help us to explain how cocaine is actually going to work, because if cocaine was to overactivate these systems potentially, or hijack these systems, then it could raise your mood and raise your alertness. Okay, and I'll just put a nus on there. Oops. So alertness. Okay, and indeed cocaine does hijack the monoaminergic systems. Okay, so let me explain how this works. So, I've now explained that you have nerve cells which release these different monoamine neurotransmitters, and I should stress that a nerve cell will release one of these. So you will have a nerve cell which releases dopamine, but it won't release all of them. So it won't release dopamine, serotonin, and noradrenaline. You'll have specific nerve cells which use dopamine, specific nerve cells which use serotonin, and specific nerve cells which use noradrenaline, and they'll be in separate clusters on this picture. So this cluster was a cluster containing noradrenaline releasing nerve cells. You'll have separate clusters for dopamine releasing nerve cells and serotonin releasing nerve cells, and they provide dopamine, serotonin, and noradrenaline to all sorts of different areas of the brain, and these monoamine neurotransmitters determine the activity level in those different areas of the brain, and through this they influence your mood and how alert you are. Okay, right. Now, when one of these nerve fibers releases its monoamine neurotransmitter into this area of the brain, so let's say we've got this noradrenaline cluster here, and it'll be releasing noradrenaline over here. Does the noradrenaline remain there forever? Well, the answer is of course no, but what happens to it once it's released noradrenaline into this area and the noradrenaline is affecting the nerve cells in this area? What actually happens to the noradrenaline? Where does it go? Well, the answer is that this nerve fiber which released the noradrenaline actually takes the noradrenaline back up after a while. Okay, so the nerve fibers which release the monoamine neurotransmitters actually recapture the monoamine neurotransmitters after a while and then store them back inside themselves to end the signal. So you do not leave the neurotransmitter in the extracellular space forever, changing the behavior of other nerve cells. It is eventually terminated. You remove it. Okay, and it's the same nerve cell that removes the monoamine neurotransmitter that released it. Okay, right. Now, cocaine works by blocking this reuptake of the monoamine neurotransmitters. Okay, so to understand this, I need to explain that there are transporters for each of these monoamine neurotransmitters. Okay, so on the nerve fiber, how does the nerve fiber actually reuptake these molecules? Well, it has a special transporter on its surface which recaptures the molecule, then takes it back inside the cell. Okay, so for dopamine, this is called the dopamine transporter, and for short it's abbreviated down to the DAT. So DA for dopamine and then T for transporter. For serotonin, it's called the SERT, the SERT. For serotonin, that's the SE. Reuptake, that's the R, and then T for transporter, so serotonin reuptake transporter. And for noradrenaline, it's called the NET, the norepinephrine transporter. So NE is for norepinephrine, and then the T is for transporter. Okay, so each of these monoamine neurotransmitters has a special transporter which will be present on the neuron that released it. Okay, so a dopaminergic neuron. And I'm sorry, I keep using the word neuron without saying neuron is the same word for nerve cell. Okay, so a nerve cell, a neuron, they're the same thing. Okay, dopamine secreting nerve cells will have dopamine transporters on their surface. Serotonin secreting nerve cells will have the serotonin reuptake transporter on their surface. Noradrenaline secreting nerve cells will have the norepinephrine transporter on their surface. Again, these are involved in then recapturing the monoamine neurotransmitter and storing it back inside the cell to terminate the signal. Cocaine works by blocking all three of these. Okay, so cocaine binds to these transporters. When it gets into the brain, it binds to these transporters on the surface of the cells and blocks them. Okay, it stops them working. Now, what is that actually going to mean? If those three transporters are not working, then the dopamine secreting nerve cells, the serotonin secreting nerve cells, and the noradrenaline secreting nerve cells cannot reuptake their monoamine neurotransmitter. So the monoamine neurotransmitters are just going to remain there. Okay, so the nerve cells are going to continue releasing the monoamine neurotransmitters because they release them at a steady rate all the time. But now what's going to happen is they're just going to build up and up and up in the extracellular fluid. Okay, so you're going to raise the levels of these monoamine neurotransmitters all over the brain, and that is believed to be what causes the cocaine high. It's believed to be why your mood goes up and you become far more alert, and then you have the consequent behavioural changes as well. Okay, so the rise in the levels of these monoamine neurotransmitters is believed to be why cocaine causes the cocaine high. Okay, so I'll just go over all of that again. Okay, so in the brain then, we have these monoaminergic systems. We have a dopamine system, a serotonin system, and a noradrenaline system. Okay, and these systems consist of these special regions that are generally in the brainstem containing nerve cells which release these monoamine neurotransmitters. So you'll have clusters which release dopamine, clusters which release noradrenaline, and clusters which release serotonin. Okay, these clusters, although they are localized in the brainstem to a very small volume of the brainstem as well, they have projections that can go over the entire brain. Okay, so they release their monoamine neurotransmitter all over the brain. Now, what are these actually deemed thought to be important in? Well, they're thought to be important in controlling things like mood and alertness. Okay, so they are thought to control the level of activity in different areas of the brain, i.e. by changing the amount of the monoamine neurotransmitter that you release into that area of the brain, you can change how active that portion of the brain is. Okay, and they're thought to be extremely important in controlling your mood and alertness, as I said. Cocaine then works by completely hijacking this system and putting it into overdrive. Okay, and it works by blocking the reuptake of the monoamine neurotransmitters, all three of them. Okay, and this means that the monoamine neurotransmitters are just going to build up and up and up and up. Okay, so you're going to get dopamine, serotonin, and noradrenaline going up all over the brain, and these are going to change activity levels all over the brain, and that's believed to be why your mood changes, your mood elevates up, and indeed your alertness elevates up, and that's believed to be why cocaine causes the high. Okay, so I think we'll have a break there, and in the next video what we'll talk about is why it causes the come down, okay, and then we'll talk about what is understood about how it causes addiction.